Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. To synthesize 1-butene, a 4-carbon terminal alkene, from ethanol, a 2-carbon compound, we need to extend the carbon chain by 2 carbons and introduce a terminal double bond. Step-by-step reasoning for option C. Moving on to the next step. Ethanol, CH3CH2O, is treated with HBr and heat. This converts ethanol to bromoethane, CH3CH to Br, via an SN2 type substitution under acidic conditions. Moving on to the next step. Bromoethane, CH3CH to Br, is treated with NaCCH, sodium acetylide. Sodium acetylide acts as a nucleophile in an SN2 reaction, alkylating the bromoethane. The acetylide carbon attacks the electrophilic carbon of bromoethane, forming 1-butyne, CH3CH to CCH. This extends the carbon chain from 2 to 4 carbons with a terminal triple bond. And for the final step, 1-butyne is hydrogenated using H2 with Lindlar's catalyst, poisoned palladium. Lindlar's catalyst performs a S-Wien selective partial hydrogenation of the triple bond, converting the terminal alkyne to the terminal alkene, 1-butene, CH2 is equal to CHCH to CH3. This gives the CIS-Z addition, but for a terminal alkene like 1-butene, there is no geometric isomerism issue, we get 1-butene directly. Why other options fail? Option A. NaCCH reacts with ethanol. Ethanol is not an alkyl halide. Sodium acetylide would simply deprotonate ethanol rather than alkylate it. No C to C bond formation occurs. Even if we consider ethanol reacting, the product would only be 4 carbons, but the sequence skips conversion to a leaving group. Actually, NaCCH plus ethanol gives no useful alkylation. This sequence is invalid for chain extension. Option B. Same problem as A. For step 1, additionally NH3 gives a transalkene, Birch-type reduction, but the starting sequence is flawed. Option D. Step 1 gives bromoethane. Step 2 uses coke, CH3, 3-DMSO, which is an elimination to give ethylene, not useful for chain extension. Step 3 then tries to react ethylene with NaCCH, which is not a valid SN2 reaction on an alkene. This sequence does not logically produce 1-butene. Therefore, the correct answer is C. Therefore, the correct answer is option C.